So my name is Michal Svoboda, and with my colleague Jakub Sekera, we will talk a little bit about how do we manage a multitude of different projects in the cloud. Actually, is kind of very similar to the talks we have heard right before. So this will be actually a practical application of those approaches. And just to give you a little bit of the background of how we operate, we are a company that develops a lot of cloud-based security products, and like everybody else, we need to work on data. We need to work on data on the cloud, and that means interactive data access, because how else are you going to run your big data queries? You can't run that on the laptop. So let me actually rephrase that and stress it out. This is not the situation where you would develop, then have a deployment to the cloud and then let it run. And even some companies have that done by different teams. But this is where you need to play in the cloud. And there is no testing prior to deployment, because you are playing with ideas. And you need to do that in a secure manner so that you're working on the live data, on the customer data. So what we thought is we would create an internal product that is called the Convenient Sandbox. Yeah. The convenience comes from the fact that it's safe and it doesn't stand in your way as you're trying to play with the data. And I'm going to show you how this works from procedural standpoint, and Jakub is going to give you a short demo of the technical parts. And for you to understand how we arrived at this point, I will start with how we failed. Yeah. So the initial approach was, as everybody, we are going to the cloud, so we have an account. Actually, we have the account. Yeah, so one account, and everybody is there and needs to work, needs to develop, needs to play with the cloud, so they will get an administrator privilege. Because how else are you going to, even to do something little as a create a resource or grant permissions to the resource, you need to be an administrator. The problem with that is that the people only feel responsible for the thing they put in the cloud for themselves, not everybody else. And there is no shared concept of I don't want to break something that somebody else put there, or I don't want to make a security problem or so. So we have a lot of unclear responsibility, especially for the baselining parts, like the account itself and these things. And out of that, we have a mess, right? So how do I define mess? Mess is when it's unclear who owns a resource. Maybe it's an employee who has already left the company. There is a concept of tagging, but it doesn't always work, and people not always tag their resources. There is unclear billing, like resource consumption is very unclear. You could say if people tag their resources, it should be possible to associate those costs, but try that with the logging that's centralized for the account, right? And that's very hard to do. So, and then there is security mess, right? People make mistakes, open things accidentally, and so on. So to get out of this problem, we had this bright idea that you're probably familiar with. We will make another team that will kind of control the other teams and make some order in the mess. But there's a problem. How are you going to do it? There's two ways. Either you revoke all the administrator privilege, and then the team kind of stands in the way, because everybody waits for the platform team to put something in the cloud. Or you keep the administrator privileges, and then what happens, everybody goes around the platform team, and they turn into a sad bunch of cops that hunt people around to not make the worst of the stuff. Yep. And so what finally clicked with us is this keyword, right? ownership. Yeah, who is responsible for the mess? And like I said, the people who play in the cloud or develop in the cloud, they would be feeling responsible, that's no problem, but only for the stuff they put there, they own. Yeah. So for that matter, we flipped it around, and we created this transition from platform team to a service team. And so rather than getting in the way of people playing in the cloud or trying to control them or cop them or police them, we would have a service team that solves a need that the actual developer can call for help, but they don't need to, because the developer is responsible end-to-end for everything they do. And this is very similar to the service model you have in the cloud. Yeah, so there is, if you know the shared responsibility model, for example, if you provision a virtual machine, the cloud provider will give you the hardware and make sure it is running, but you are responsible for what you put in it. So in this case, we will create the account and provision the account with all the bells and whistles, and the developer team or the research team still maintains ownership and full control. Yeah. And if they don't play by the rules, then the service is moot, right? We don't help them. So just to give you an idea what the solution has, where are we at currently? So first thing, for everyone to own their own stuff, they need their own account. It's not possible to do like you have your own VM or your own network, you have the whole account, the billing entity basically, yeah. So that's the first thing. We can create many accounts and distribute them. To make sure, to protect the data in the account, we have egress firewall, which is deny by default concept. That's known from the days of data centers, I think, but not very much in line with how people operate today. But anyways, if you have deny by default, it works. If you have allow by default and try to deny afterwards, it doesn't work, right? So we have deny by default. To get the other way inside, we have ingress gateways, or the popular keyword now is the service edge, right? To get inside of the sandbox. And the service team is responsible for monitoring the account, for giving you information. You are not compliant with something, or you have a problem here, blah, blah, blah. But not for solving the problem, right? Just giving you information, and for updating the infrastructure that they have deployed. And to make it easier for everybody in the research team and in the development team, there are also a little, there's a modular approach that you can use services from other teams, perhaps, to deploy your Kubernetes cluster on top of this account, and so on. You have some shared logging service. We use Datadog to date. You can have a CI/CD deployed in your account, and also to actually work with the account itself. It's not like you have a shared code or anything like that. There is an actual API. So the developer or the research people, when they get in the account, there is a fixed and documented API how they can interact with the deployed resources. And so this is from the theoretical part, and here I will switch to my colleague and friend Jakub. He will give you some practical information.
Yeah,
thank you.
Thank you. Hello, everybody. So let's talk about the process part and the implementation part as well. So as you can see here, we came up with this internal process, where the service team member will pre-create the pool of AWS accounts. Usually there are like 5 AWS accounts in that pool. Why pool account? Because we would like to expedite the time, the lead time, from the time when developer asks for account to like the final delivery. As Michal mentioned, these AWS pool accounts already contains the various third-party integration. There is enabled security and application logging, and so on. So, and there is other side, it's like development team. So one developer is usually per project will clone existing template and field important information. You know, it's like, for example, which egress rule should look like, how should the subnet size, like network size, should be big, how you should name the AWS account, and so on. And once this request or ticket is created, is passed to service team member, and usually within minutes or at least like up to 1 hour, AWS account is created or like assigned and ready to be used. At the same time, we are creating support channels in our like communication application, where everybody or like every team per project has their own channel where we can discuss, you know, like some additional settings or the problems which they have with this account. So from the AWS VPC or like network part of view, we created 2 separate zones. One is user zone, which basically supports the sandbox idea, which, like, you know, it prevents developer to, for example, extract data to some external location, but at the same time, he can or she even deploy like their database, compute, EKS cluster, and there is like sure that he will not break anything in this user space. On the other hand, there is restricted space, which is under control of service team. It's the place where, you know, ingress and egress is deployed, and the tenant, like developer, must not deploy any resources to this restricted space. And we do have alerting and monitoring. So, for example, if someone will place EC2 instance or will change our egress rules, we will be alerted. So, yeah, that's the time for a live demo. So let's connect, and I hope it will work. Yeah, so now I'm connected, you know, through the Wi-Fi, through the VPN, and yeah, you can see my screen.
I think you need to exit the presentation mode in the PowerPoint.
Okay, thank you. Yeah, so now I'm connected to my developer's machine, so let's log in.
Big suspenseful moment, right? Live demo approaching.
Yeah.
Yes, exactly.
So let's talk about our repo a little bit. As you can see, we do have various projects in this repo. It's either AWS base, where these third-party integration are deployed. Then we have AWS DNS, AWS images. I will talk about AWS VPC today, but we do have like security logging and common share libraries and so on. I have to mention that everything is written in AWS CDK, and test-driven development. Maybe the question is why we choose AWS CDK. I think is that we are deploying to AWS, and it's like native from AWS. Either people and guys from AWS are using this AWS CDK internally, and I think it's like testability as well, and a lot of these things. And it's like not writing YAMLs or JSON, it's like really writing in Python. So let's see. I will run tests, and then we can talk about. Basically, this is like shell script, which is basically wrapper, and is like running PyTest. So in the meantime, we can go to the AWS VPC projects, and as you can see, we have 4 folders here. And there is stacks. Stacks corresponds to CloudFormation stacks. It's basically, you know, one CloudFormation stack. It's like a group of AWS resources. And as you can see, AWS VPC project contains, or I don't know, 7 or 8 like CloudFormation stacks. So if I will show you AWS config, for example, for pool number 7, you can see that it's really on the high level that we are creating in this region. That's a workspace. You can see that there is a subnet size which you can choose, number of availability zones. This is like we are creating 3 user spaces in one VPC, and then is like a for loop where you are allowing egress to Datadog and to some Kubernetes autoscaler, and you are on top of basic or like default AWS VPC endpoints. We are adding SQS, DynamoDB, and LLB. So if we will go, so it's like on the high level. If we will go like deeper, we can go to the VPC stack. Yeah, I will just resize. I think the important part here is like the VPC creation. There are some settings like above and below, but basically with this construct, we are creating AWS VPC with VPC flow logging and DNS logging enabled. For this CloudFormation stack, we have corresponding tests. We have various tests, but for example, here we are testing VPC configuration that, the VPC which was created has enabled DNS support and DNS hostname, or we are checking that, the logging is enabled and everything is fine. So as you can see, these tests for AWS VPC project finished in less than 2 minutes. I have to say that we are deploying these resources to our development AWS account, and cold start took around 35 minutes. But we are doing this cold start just once per 2 weeks, because every week we are doing nuke of this AWS account, and then that's ready for service team developers to develop their resources. The important part is as well that these tests are workspace. So at the same time, several developers can have exact copy of this infrastructure, and the workspace is based on naming. I will show you later in the UI console. So until now, it was everything from service developer side, but from the actual developer, as Michal mentioned, we are exporting APIs and various parameters as very SSM parameter store variable. You can imagine the place where we are storing and exporting parameters. And when developers would like to, for example, either deploy EC2 instance via Terraform, he will just use this data construct. Basically, he import in this case VPC ID, but there are other SSM parameters as well. And then if we go down, it's really, in this case, creation of the AWS EC2 instance using these parameters. I have to say that our developers created EKS Terraform module internally, and this is of course compatible with this Terraform module as well. So let me switch to the console. Yeah, you can see that there are 84 stacks in CloudFormation. I'm logged into development account. So if I go with my name, you can see 21. But if I choose our other developer, you can see that he has either more, because he deployed not just this stack, but other stacks as well. And if we go to the parameters, and I will go, for example, for my parameters as well. And I can open, for example, this one, VPC ID. You can see that this is the value which is stored in this parameter, which can be used then by our developers. So I think that's it from live demo. Let me see, I forgot something. No. Do you have something to add?
Yeah, everything clear so far? Any questions to this part? Okay.
So I will go back to presentation. Sorry. So there are some metrics. Currently have 16 AWS accounts, and not every account have VPC, so that's why we have 10 VPCs. We have really 7 different projects using this our service as a service, and there are just like 2 monthly requests for change. So that's from metrics, and that's the feedback I gathered from our developers from like last week. As you can see, they are satisfied that we have dedicated support channels, that there are really quick changes, and the accounts are fresh and according to their needs. They are really satisfied with the ingress, that they just create like a Redshift database, and then we will take care of the ingress so they can connect to the database outside, considering that there is like a correct security group and so on. And that we have well-documented process, because we have, like as I mentioned, templated requests, and on the Confluence we have like how this service look like into such details. And what they are missing, it's like a sort of compliance reporting, that they would like to probably see the billing, or like if they created like some resources in wrong place, that they would like to be alerted automatically. And yeah, that's it from our side.
Okay, so thank you very much. So again, there is time for your questions. The same principle. If you have a question, just raise your hand.
Okay. Hi, and thank you for the nice talk. It is nice that somebody cares and polishes these AWS environments and cleans them up. And so my question is, you mentioned that there are only 2 requests for change per month, and I wanted to ask, so do you have to plan ahead and inform everybody involved like about this system? Because from my experience, or first thing I thought about when I saw how you have the team set up, is there, if there is going to be pinging around between the dev team and the service team, like it could increase development time, or so to get everybody in sync, or maybe someone is in holiday so they don't reply and so on. So do you plan ahead, and how do you bring it down to just 2 requests per month?
Yeah, thank you for the question. We set up like internal SLA that for this type of task, the expected resolution is less than 24 hours, but this changes most of the time. Looks like that someone would like to allow something on the egress, it's like really 1 line, or he would like to add new VPC endpoint or policies, and again, it's just 1 line usually. If there is something big, like the customer, like developer is asking for some new feature, that has to be, of course, properly planned. The same stands for transition of these AWS accounts, because as I mentioned, we already pre-created the pool. So when someone asks for new AWS account, we can really like in less than 24 hours transfer this account to the developer.
Hello, thank you for the presentation from me also. I just wanted to ask, you said that your team is responsible for compliance and checking all the development teams. How do you tell them that some of their developer has accidentally maybe deployed too many resources, and how to do that without blaming the team? Or is there some automated information that your team doesn't send out per se for this?
Yeah, I can take this one. It's more of a procedural question. So first of all, no, the service team is not responsible for the compliance of the environment. It is the team who owns the environment, that they need to make it compliant, secure, and so on. And because that's a lot of work, usually, especially if you're doing data science in the cloud on customer data, they can call the service team to help to pre-build an environment. That's the idea, yeah. And then the compliance, they can say, because we use this sandbox and so on, we are compliant with XYZ. When there is something not compliant, well, it's easy. There's no blame. If somebody notices, or there are also automated alerts that goes to the research team or development team, and FYI, this is happening. So it's up to you to figure out what you want to do about it. Yeah. Does that answer the question?
Yes.
Yeah.
I didn't. Sorry, I just want to say I didn't understand that the service team is working together with the development teams on the first setup. Thank you.
Yeah.
Hi, thanks for the presentation. I'm just trying to understand the scope of a project, because you have one project per account. So if you have 100 projects, do you have 100 accounts? And also follow up on that, so let's say if one person is working on multiple projects, how do you keep track to what resources that person has access?
Yeah, I'm not sure I understand the keeping track of. Can you clarify that?
For compliancy, I guess you need to just keep track what resources a person has access to, right?
Oh, I see. Maybe it was not shown here. Let me go here. But one of the services is managed monitoring, yeah, and managed logging. So, like the previous question, the compliance and auditing is deferred to this service. If I want to do like an audit of the egress rules, you have seen in the code, it's very easy to read. Yeah, I don't have to log into some environment and check it there, so I can do that very easily. So part of the requirements was that these things need to be easy to audit. Yeah. And as far as the project scope, this is up to the discrimination, I would say, the determination of the research and development teams. Yeah, all they want to do is clear ownership, and it will become quite apparent quite early when something needs to split off, because there will be ownership issues. Yeah. Does that answer the question? Yeah, thank you.
Okay, so it seems there are no any other questions. So thank you very much again for your talk.
Thank you as well. Enjoy
There's
lunch.
one more.